Solving radical equations. Radical equations are the equations that the variable is under a radical, which is called a radicand. So this is the notation of the radical. And every radical has a number here, which is called index. If you see a radical that doesn't have any number for the index, means it's 2. So that's why we read this one, the square root. And when a variable like x is under the radical, that makes a radical equation. But other indexes like 3 and 4, they will be written with the same number. Now, the question is how we can solve a radical equation, a radical that has variable under a radical, an equation. So to solve radical equation, we have to isolate the radical expression first. And once the radical is isolated, we need to raise both sides to the power that cancels the radical. And that power must be the same number as the index of the radical. And then the remaining equation, whatever it is, so since we have no more radical, we solve this equation and then check the answer to make sure that we can accept those solutions and we don't have any extraneous solutions. Now, let's look at example 1. First of all, step 1, we have to isolate the radical expression. Radical expression means this part. I want to isolate this. So on the left side, next to the radical, I see a 4 and I see positive 3, plus 3. So both of them must be moved and canceled. To cancel positive 3, I need to subtract 3 from the both sides. 23 minus 3 is 20. Then I need to cancel 4. 4 is multiplying by the radical, so I have to divide both sides by 4. So now I have the radical 2x plus 7, which is equal to 5. Okay, I'm done with the step 1. The radical is isolated. Now, in step 2, we have to raise both sides of the equation to the same power as the index. So this is a square root because there is no number for the index. If it's a square root, you need to raise both sides to the power of 2. Both sides, left and right. Because power and radical cancel each other, so we just have 2x plus 7 on the left. And on the right, since I have a number, 5 squared means 5 times 5, which is 25. That's the resulting equation. Now we just need to solve this equation. This equation is a linear equation because the power of x is 1. So that means I have to keep the x on the left and move the numbers to the right. And if I subtract 7 from the both sides, I will get 2x, which is equal to 18. And then divide both sides by 2. And we get x equal to 9. Now the question is this the solution? Can we accept this value as a solution? We have to go back to the equation and plug in x by 9. Replace the x by 9 because we want to make sure that under the radical it's not negative. And when we check the answer, we just want to make sure that if the index of the radical, is even number like 2 or 4 or 6, under the radical must be positive. That's all we do check. Under the radical must be positive. What about if the index is odd, like 3 or 5? It doesn't matter. We can have both negatives and the positive under the radical, so we don't have any restriction, and we can accept all the solutions. So if I replace the x by 9 inside the radical, so I will have 2 times 9 plus 7, which is 2 times 9 is 18. 18 plus 7 is 25. It's positive, so it's okay. We don't have any problem with that. And if I Find the square root of 25, which is 5. Replace it here. So 4 times 5 is 20. 20 plus 3 is 23. And you will see that gives you a true statement. Let's look at another example. For this one, again, we have to isolate the radical expression, this part. To isolate this one, I have to subtract 4 from the both sides. And negative 11 minus 4 is negative 15. Then I need to divide both sides by 5 to isolate the radical. And this radical's index is 3, which means it's the cube root. Is it okay if the other side is positive? Yes, because the index is odd. So what do we do now? We raise both sides of the equation the power of 3 because the index is 3. Power and radical cancel each other, so we just have x minus 8. And negative 3 to the third power means multiply negative 3 by itself 3 times, which is negative 27. And then we have to isolate the x. Add x to the both sides, add 8 to the both sides, and we get x, which is equal to negative 19. That is the solution. And if I go back to check this answer, if I replace the x by negative 19 under the radical, negative 19 minus 8 gives me negative 27. The cube root of negative 7 is negative 27 is negative 3. Negative 3 times 5 gives me negative 15, and negative 15 plus 4 gives me negative 11, which is a true statement. Now let's look at some examples that involves 2 or more radicals. But we are still following the same steps. Okay, for the part A, we want to solve this equation, but this equation has 2 radicals, one radical on the left and one radical on the right. We said that first step is isolating the radical. Okay, which radical must be isolated? Doesn't matter. Make sure that at least one of the radicals is isolated. Right now, in this equation, both of the radicals are isolated. You don't see any other number next to the radicals on each side. Then, step 2, we raise both sides to the power, which is the same as the index. The index is 3, so we raise both sides to the power of 3. Power and radical cancel each other, so we just have 4x minus 3 on the left and 3x plus 2 on the right. Okay, now we just have to solve this equation. To solve this one, since it's a linear equation, x on one side, numbers on the other side. So move 3x to the left and move negative 3 to the right. And now we have x, which is equal to 5. And that is my solution. Now let's check. Let's check the answer as well. See if it gives us a correct solution. I'm going to go back to the equation and replace the x by 5. If I replace the x by 5, let's see what do we get. So on the left side, we have 4 times 5, which is 20. 20 minus 3 is 17. So we have cube root of 17. On the right side, 3 times 5 is 15. 15 plus 2 is also 17. And you will see that we get a true statement. So that is correct. Yes, that is my solution. Another example. As you see in this example, we also have 2 radicals. But when we want to solve radical equation, we have to make sure that one of the radicals is isolated. Right now, the radical, in this example, the radical on the right side is isolated. So I don't need to do anything else. So I can keep that one and then move to step 2. Step 2, raise both sides not one by one, the whole left side and the whole right side to the power of the same number as index. So the index is 2, so I will raise both sides to the power of 2. If I raise the right side, power and radical cancel each other, so we just get x plus 9. But what will happen on the left side? On the left side, inside the parenthesis has 2 terms. Okay, so when I say square root of x plus 1 with the second power, I cannot just put the power on top of each term because there is addition between them. So what do? When a parenthesis has a power of 2 means we have to multiply the parenthesis by itself. I have to multiply the 2 same parentheses. And I multiply one by one. Square root of x times the square root of x, which is the square root of x squared, because square root of x times the square root of x is the square root of x squared. Power and radical cancel each other, so the answer is just x. A square root of x times 1, which is the square root of x. 1 times the square root of x, again, is the square root of x, and 1 times 1, which is 1. And if I combine like terms, 1 square root of x plus 1 square root of x is 2 square root of x. Bring down the rest, and that is my answer. So I have to write that one as the answer for left side. Okay. We usually raise to the power to cancel the radicals. We did this time, but we still have a radical in our answer. And that's because we already had 2 radicals. So what do we do next? Again, we have to isolate the radical and follow all the steps. So go back to step 1, isolate the radical, raise to the power, and then solve. We have to repeat those steps until there is no more radical in our answers. Okay, so again, I move back to step 1 and isolate the radical expression. To isolate the radical, I need to move x. I need to move 1. So we just have 2 root x, which is equal to 8. Then I have to divide both sides by 2. Now it's time to raise to the power. We raise step 2, we raise both sides to the power of 2 because the index is 2. And you know this time root and the power cancel each other. And the other side, 4s squared is 16. And that's the final answer. So remember, when you are raising both sides to the power of the same as index, if you have 2 terms that are adding or subtracting or more than 2 terms, you need to do it like this. You have to multiply that by itself to see what you get. So please don't put the power on top of each term separately. And repeat those steps, step 1 and step 2, that you can cancel all the radicals. Next example, you want to solve this equation. Again, we're following the same steps. Step 1, isolate the radical expression. To isolate this one, I need to move 4, so I will add 4 to the both sides. Okay, now step 2, raise both sides to the power of 2. On the left side, we just have 1 radical, so radical and power cancel each other, and you have 5x plus 56. But on the right side, we have 2 terms that are adding together, x plus 4. So if I want to find x plus 4 squared, that means I need to multiply x plus 4 by x plus 4. And if I multiply x times x, x times 4, 4 times x, and 4 times 4. Combine like terms, so it gives us x squared plus 8x plus 16. And I will write the answer here. Now we need to solve this equation. No more radical, okay? We don't need to repeat those steps again because there is no more radical. But as you see, this is a quadratic equation because x, which is the variable, has a power of 2. And to solve quadratic equation, I need to move all terms to one side, and one side gets 0. So I want to move 5x plus 56 to the right side. So I will subtract both sides by 5x. I will subtract both sides by 56 to move them to the right. And we have x squared plus 3x minus 40, which is equal to 0. Now this is the equation that I need to solve. And to solve this one, I can use AC method because A is 1, B is 3, and C is negative 40. A times C and B. We are looking for two numbers that if I multiply them together gives me 40, add or subtract them gives me 3. The question is, what numbers gives you 40 if you multiply them together? So for 40, we have many options. We say 1 times 40 is 40. We can say 2 times 20 is 40. We can say 4 times 10 is 40. We can say 5 times 8 is 40. But which one of these options gives me 3 if I add or subtract? 5 and 8. So we should have positive 8 and negative 5. Because 8 minus 5 gives me positive 3. So I can open two parentheses. X, positive 8, negative 5. And then set each parenthesis equal to 0. If x plus 8 is equal to 0, what is the x? If x minus 5 is equal to 0, what's the x? Okay, now it's time to check our solutions to see which one is the actual solution. I have to go back and replace them into the equation. If I replace the x by negative 8, let's see what will happen. Don't forget to replace the x, both of the x's, this one and this one. Both of them must be replaced by negative 8. Inside the radical, 5 times negative 8 is negative 40. Negative 40 plus 56 is 16. And the square root of 16 is 4. And 4 minus 4 gives me a 0 on the left side. But on the right side, we have negative 8. Is this a true statement? No. So negative 8 cannot be a solution. We repeat that for 5. This time we replace the x by 5. If I replace the x by 5, 5 times 5 is 25. 25 plus 56, which is 81. And the square root of 81 is 9. 9 minus 4 is 5. And the other side is also 5. So yes, this is the correct answer. So we can only accept 5 as a solution.